Complex numbers എന്ന ചാപ്റ്ററിലെ കുറച്ച് ഇമ്പോർട്ടൻറ്റ് പോയിന്റ്സ്. റൂട്ട് ഓഫ് -1 ഈസ് ഈക്വൽ ടു I. Here I stands for the Greek letter iota. Here root of -1 is considered as an imaginary number. Numbers of the form a plus ib is called a complex number and it is denoted by the letter Z. Here a is called the real part of Z and b is called the imaginary part of Z. For example, Z is equal to 2 plus 3i. Here the real part of Z is 2 and the imaginary part of Z is 3. Another example, Z is equal to 3 minus 4i. Real part of Z is 3 and imaginary part of Z is minus. Next is powers of I. I said that I is equal to root of -1. What is I square? I square is I into I. So it is root of -1 into root of -1. It is root of -1 the whole square. So it is -1. Then next is I raised to 3. It is I raised to 2 plus 1 or I raised to 2 into I raised to 1 minus 1 into I. It is minus I. And what is I raised to 4? I square the whole square minus 1 the whole square 1. So you got 4 results. I raised to 1 is I raised to 2 is -1, I raised to 3 is -I and I raised to 4 is 1. Then we can find the other powers of I raised to 5. You can find it by writing I raised to 4 plus 1. I raised to 4 into I raised to 1. You know I raised to 4 is 1. 1 into I. Suppose if it is I raised to 9. Same case I raised to 8. 8 എടുത്തത് എന്താ കാരണം 4ന്റെ മൾട്ടിപ്പിൾ ആയതുകൊണ്ട് 8 plus 1. So in similar case I raised to 8 into I raised to 1. 1 into I. So you can see that I raised to 1, I raised to 5, I raised to 9, I raised to 12 plus 1, 13, etc. will be equal to I. Similarly, we can see I square, I raised to 6, I raised to 10, I raised to 14. These all will be equal to -1. I cube, I raised to 7, I raised to 11, I raised to 15, etc. will be equal to -I. I raised to 4, I raised to 8, I raised to 12, etc. will be equal to 1. So easily we can find the powers of I. Two complex numbers are said to be equal if a plus ib is one complex number, other is c plus id. These two complex numbers are said to be equal if a is equal to c and b is equal to d. Next is modulus of a complex number. Modulus of a complex number. You can represent a complex number using x-axis and y-axis. Suppose z is equal to x plus iy is a complex number, then the real part is denoted by the x-axis and the imaginary part is denoted by the y-axis. So the point xy will denote the complex number z is equal to x plus iy. Then if it is p, then OP. OP, it is the distance from the origin to the point P, and this distance is termed to be the modulus of Z. Modulus of Z. This distance x, this is y. So using Pythagoras theorem, you can say that is x square plus y square is equal to, you can also represent mod z by the letter r. So x square plus y square is equal to r square, or r is equal to, r means modulus of z, that is equal to root of x square plus y square. So this is a non-negative real number. Non-negative real number. Then next we have to find next definition, conjugate of a complex number. Conjugate. Conjugate of z is denoted by z bar. It is a minus ib. So in order to get the conjugate of a complex number, if z is equal to 2 plus I, its conjugate is 2 minus I. Change the sign of the imaginary part. Now we can find the relation connecting z, z bar and mod z. Z bar and mod z. What is z into z bar? A plus ib into a minus ib. So it is a square minus ib the whole square. A square minus I square b square. A square is minus 1 into b square. A square plus b square. So z into z bar is a square plus b square. We know that modulus of z is root of a square plus b square. So mod z square is, it's raised to 2, or it is a square plus b square. From these two you will get z into z bar, that is equal to a square plus b square, or that is equal to mod z square. So you will get the relation connecting z bar, z into z bar is equal to mod z square. So what is multiplicative inverse of z? Multiplicative inverse of z is 1 by z. From this relation we can find 1 by z. Take z to the opposite side. So mod z divided by, conjugate of z divided by mod z square is 1 by z. So 1 by z is equal to z bar divided by modulus of z square. So in order to find the multiplicative inverse, either you can use this result or find the multiplicative inverse of 1 plus I. 1 plus I യുടെ multiplicative inverse കണ്ടുപിടിക്കാൻ പറഞ്ഞാൽ ഒന്നുകിൽ equation apply ചെയ്യാം, or you multiply both numerator and denominator by its conjugate. So automatically in the numerator you will get 1 minus I. എന്താണ് 1 minus I? Conjugate. And 1 plus I into 1 minus I is mod z into z bar, it is modulus of z square. 1 square minus I square. 1 minus I by 1 minus I square is minus 1. So it is 1 minus I divided by 2. So in this way we can find the multiplicative inverse of z. One question, express in the form a plus ib. Express in the form a plus ib. I raised to minus 35. You have to express I raised to minus 35 in the form a plus ib. So the ഏറ്റവും എളുപ്പമുള്ള മാർഗം multiply numerator and denominator by I raised to 36. അതായത് ഈ നെഗറ്റീവ് കളഞ്ഞാൽ നമുക്ക് എളുപ്പമുണ്ട്. ഈ മൈനസ് കളയണമെങ്കിൽ ഇതിലും വലിയൊരു നമ്പർ ആഡ് ചെയ്ത് വന്നേ ഒക്കത്തുള്ളൂ. അപ്പോൾ 35 കഴിഞ്ഞു വരുന്ന 4ന്റെ മൾട്ടിപ്പിൾ ഉള്ള ഐയുടെ പവർ എഴുതുക. So it is I raised to minus 35 plus 36 divided by I raised to 36. It is 4 into 9. So automatically it will be 1. So minus 35 plus 36 is I raised to 1 by 1. So answer is I. This is the most easiest method to find the negative power of I. കോംപ്ലക്സ് നമ്പേഴ്സ് എന്ന ചാപ്റ്ററിലെ എക്സസൈസ് 5.1 ചില ചോദ്യങ്ങളാണ് ചെയ്യുന്നത്. ഫസ്റ്റ് ക്വസ്റ്റ്യൻ 5i ഇൻറ്റു 3/5i. ഈ 5 ഈ 5 ക്യാൻസലായി. ദെൻ 3i ഇൻറ്റു I സ്ക്വയർ. അപ്പോൾ 3 ഇൻറ്റു I സ്ക്വയറിൻ്റെ വില -1. സോ ഇറ്റ് ഈസ് -3. When you write in a plus ib form, you should write this as -3 plus I0. Fourth question, you have to expand. First you have to expand 3 into 7, 21 plus 3 into 7. So I27 plus I7 plus I into I square. Instead of I square you can write -1 into 7. So 21 minus 7 plus, here it is 27 plus 7, 34i. 21 minus 4, it is 14 plus I into 34. That is the answer. Next question is 1 minus I raised to 4. So you know what is 1 minus I, the whole square. So first you have to find 1 minus I the whole square, then the whole square. So that is equal to 1 square minus 2i plus I square the square. 1 minus 2i